Learning goal. By the end of the class, we're going to be able to sort limits out into the indeterminate and determinate. And by the end of the class, we're going to use our properties to evaluate both kinds of limits if they exist. By the end of the class, we're going to practice our inquiry skills by solving a wide range of limits that exist in mathematics. Okay, let's get to it. So, we've been using limits already because we've been talking, what is the limit as h approaches 0? What's the limit as x approaches a being some particular place that you're trying to figure out what the slope is, what the IROC is. So we've kind of been talking around limits a bit, but we need to get some more specific details about limits. So here's what this says. This says that the limit of a function as x approaches a exists if the limit of the function approaches the same value coming from the right and from the left. Let me just remind you. In fact, you've seen. I'll give you an idea of what I mean by from the right and from the left. I'm going to do a quick. I'm going to use one of these styluses here. So if you remember doing rational functions, they tended to have asymptotes, vertical asymptotes, horizontal asymptotes, etc., etc. Let's talk about one that has a vertical asymptote. And let's say the vertical asymptote was, I put a straight line in to represent that vertical asymptote. Let's say that vertical asymptote, and I'll put it in red. Let's say that that vertical asymptote was somewhere around here. And let's say that the function itself looks something like, and I'm just going to make this up here, looks something like this. Put this in green. Okay, that's ugly. Let me try that again. Let's say the function looks something like that, not that much better, but anyway. So remember that we would ask, what is the, we would ask that as x approaches, let's say this vertical asymptote was, let's say this was 5, I'm just making that up. As x approaches 5, we talk about 5 minus, and as x approaches 5 plus. What 5 plus meant, and I'm just kind of going over stuff that you should have learned from advanced functions. What 5 minus meant is as you approach 5 from the left-hand side, so as you approach it going this way, right? Well, in this case, the answer would be positive infinity. It's shooting up towards positive infinity. In the other case, as you approach 5 from the right, which means that you're going at it from this way, you're approaching that asymptote from this side, the function is actually going down. So we'd say that as you approach 5 from the right, the function is going towards minus infinity, the memories, as Danny says. So that's stuff what we did in advanced functions. So that's related to what I'm asking you about here, right? If the limit of the function is the same coming from the right or from the left. So in a case like this function doesn't have a limit because the limit coming from the left, right? If you remember, this answer for this would have been equal to infinity. The limit coming from the right would have been minus infinity. Well, those are not the same. Those are clearly not the same. So in that case like that, if the limit coming from the right and from the left are not the same value, which is what it says here, then we would say that the limit does not exist. They have to have the same value coming from both sides. I'm going to name the limit L. So the limit may exist. Here's a little important point to remember. The limit may exist even if the function does not exist at that particular value. That just sounds a little weird to say that. But the function may be undefined at a particular value, yet the limit actually exists, right? The limit may exist, but it may not be equal to the function at that value. Let me give you another example of what I mean by that. Remember, we had functions that had what we called a hole in it, right? So I'm just going to make something up again on the fly here. So let's say the function looked like this, where there was one spot. Again, this is something you should remember from advanced functions. So if I asked you, let's say this hole occurred when, I'll use 5 again. This hole occurred when x was 5. So the fact is, this function does not exist at 5. There's nothing. There's nothing there, right? The function has a hole at 5. It's undefined at 5 because of the hole. But as you approach 5 from the left, from the right, I should say, and as you approach 5 from the left, you're still, let's just say that let's say this hole was at 5 minus 7, and I'm just making up a number here. You've never seen this, Stephen says. You've never seen us talking about, let me go back a bit then, Stephen, because I want to be sure that you have seen at least this, where we talk about as x approaches a vertical asymptote from the left and from the right. You've seen that before, haven't you? Please say yes, but that's that's the answer. Yeah, the whole thing. Oh, well, that's something you should have done in advanced functions. But at any rate, so functions can have holes in them. Just FYI, functions can have holes in them. And I'm saying that this particular, and that usually happens, let me just give an example of when that happens. It happens when, I'll give you an example of when it happens. So let's say you had a function that was x plus 5, x minus 5 over x plus 5, right? The function does not exist at minus, actually, I should have used x minus 5 as the example here. The function does not exist at x at 5 because, I think you'd agree with me on this, Stephen, because at 5, the truth is that this thing is undefined, right? But it's still, when you cancel this down, you're going to end up with a straight line, which is the x plus 5. Right? So even though it's going to behave a lot like the x plus 5 function, the original function does have this hole in it, this point in it, which is for which the function is undefined. So maybe I should have used a straight line in this case. But anyway, I'll just keep up with the quadratic function. So this function is not defined at 5, but it's defined everywhere else. And here's the thing. As I approach the 5 from the left, I'm still getting closer to the y value of minus 7. As I approach it from the right, I'm still getting closer to the value of the value of 5 at minus 7. So even though at 5 the function doesn't exist, this does have a limit, right? Because the question is, what are you approaching? What are you getting closer and closer and closer to, even though when you get to 5, there is nothing there, right? The function as a whole, it's undefined at 5. So that's the reason that we say that what the following here. The function may exist even if f of a does not exist. That's what that first note says. So the function doesn't exist at a, there's a hole, for example, but as you get closer to a, from the left, from the right, you're getting the same number, right? And the second point says it may exist, but it does not have to be equal to the f of a. What does that mean? Well, it is possible that you can define a function that says when you get to 5, right? Hear me now. When you get to 5, the actual value of the function at 5 is, let's just make up a number. It's 3, right? So here's a value of the function at 5. The value of the function at 5 is 3, right? So the f of 5 is 3. So as you get closer and closer to 5, the function is trending towards minus 7. But when you get to actually 5, it jumps up. Sometimes they call it jump discontinuity. We're going to get to all of these terms in a second. So that's what we need to stress. Let me go back to the chart again. Right? The limit may exist even if f of a doesn't exist. That's point 1. F of a may exist, but it's not equal to the f of a. That's also possible. Right? F of a may be some other number, like in the example I just showed you a while ago, where the f of a was, I think I used 6. What did I use? Oh, sorry, 3. F of a is 3, but as it says, the limit is going to be something else. The limit is going to be 7 in that, minus, what did I say? The limit is going to be minus 7 in that case. Okay, let's do some examples to make this a lot more clear, because I know a lot of that sounds a little dodgy. So let's get to the first example. For the following graphs, f of x, find the limit as x approaches 0. All right, let me make sure you can see the graph first. All right, hopefully everybody can see that graph. So the first one is just a simple, regular quadratic function. That's it, that's all. But we still are going to use the same approach to answer the question. We're going to ask, because we're trying to find the limit as x approaches 0, we're going to ask, what is the limit as x approaches from the left? And what's the limit as x approaches from the right? We're going to compare those two things. If they're the same, then we're going to say the function has a limit, the limit exists, and the limit is whatever we think it is. Okay? So here we go. I'm going to grab my other stylus now, which is far better. Hopefully it's charged up enough. So here's what we're saying. Well, here's what we're asking. What is the limit as x approaches 0 negative? Remember, 0 negative means that I am approaching, so I'm coming to the function from this side, right? And I'm getting closer and closer. So remember, look at your x values. Your x values are declining from -4 to -3 to -2 to -1 to 0. Then it's going to go to 1 to 2 to 3 and so on. What y value is my function approaching as I get closer, my y value now? What y value is my function approaching as I move towards the function from the left? From the left, okay? Stephen's giving me 3 different answers, 2, -1, and minus infinity. That's interesting. It has to be just one. Anika and Shashi think it's 2. What do other people think? I'm not going to confirm or deny any of the others. And the answer, of course, yes, is 2. I don't know. I have it in red. The answer is 2. Look at the y value. What is the y value? Yes, Shashvan. Thank you, Kushi. Thank you, Sarah. Thank you, Taj. What is the y value as you get closer and closer to 0? As you get closer to the y-axis, right? As you get closer to 0 on the x-axis. What y value are you approaching? The answer is 2. Let's look at the other side. What's the limit as x approaches 0 plus, right? What is it going from the other side? That's the question we're asking now. So it's a different question, but is it the same answer? I don't know. You tell me. So what I'm doing now is I'm approaching it coming from this direction, from the right. What would you say is the answer this time? What y value am I approaching this time? Alexander says 2, Danny, Jordan, and people are still thinking it's 2 for some reason. Nobody have a different answer. Does anybody have a different answer? Everybody convinced that it's 2. All right, I can't fool you guys. It is 2. Okay. I just wanted you to think about it and to see if you had it, after you thought about it, maybe had a different perspective on it. But no, you're right. It's 2. All right. So when you compare these two answers, right, since the limit from the left is equal to the limit from the right, let's just write that down. So the limit as x approaches 0 left is equal to the limit as x approaches 0 right. Therefore, the limit as x approaches 0 is 2, right? Because both sides of this thing are in agreement. That's why we say it's 2. Okay, let's try this again. Now, I know you've probably never seen a function that looks like this before, but they exist, right? And we're going to look at some more like this a little later on, but they exist. So here's a function that seems to be linear on one side, and then it seems like it's quadratic on the other. Okay, so let's see now. Let's approach this again from the left and from the right. Remember, it's always as x approaches 0. So what is the limit? I'm on the right color here. What's the limit? I'll draw a line down here, actually. Okay. So what is the limit as x approaches 0 from the left? What are you thinking this time? So I'm moving this way now, right? Moving towards I'm moving towards on the x-axis, I'm moving towards 0 from the left. Okay, so people are thinking it's -1. Alexander and Anika and Jordan and Kashaf and yeah, okay, cool, okay, all right, okay. So that's equal to -1. I'm not going to argue with that. I don't know why I'm putting it in red, but I'm not going to argue with that. So let's ask the question coming from the other side now. What's the limit as x approaches 0 from the right? Same graph. What about that answer? So I'm now approaching it from the right, and everybody is in agreement again that it's 3. So there is a limit on the left, there is a limit on the right. There's a sometimes talk about left-handed limits and right-handed limits. So in this case, there is a left-handed limit of -1. There is a right-handed limit of 3. Well, it doesn't seem as if these two, not doesn't seem, it's obvious that these two things are not equal. The limit as x approaches 0 left is not equal to the limit as x approaches 0 from the right. So what we would simply say is that the limit does not exist. Okay, there is no, the limit does not exist. DNE. Right? There is a left-handed limit, there's a right-handed limit, but because the two are not in agreement, we say that the limit does not exist. Okay, let's try the next one. So hopefully everybody is okay with that. Hopefully that makes sense to everybody. Ella, how about you? Does that make sense to you, Ella? Perfect. Okay. Let's try the last one on this page anyway. I'm going to draw another line down here. And let's ask the question again. What is the limit as x approaches 0 from the left? What is that equal to? So now I'm talking about coming in from that direction. Okay, so Alexander thinks it's -infinity. Oh, a bunch of people, a lot of people are, from Stephen all the way down to Adam, are thinking -infinity. And without further ado, I'm going to say absolutely. -infinity makes sense. What's the limit as x approaches 0 from the right? Positive. Wow. On the ball. On the ball. So positive infinity. I just want to make sure everybody's okay with this though, right? Is this right for everybody? Is this what everybody else thought it was? Alicia, not for Fernando. Is Alicia okay with that? Alicia, how about you? Alicia, does that make sense? Where's Alicia? Perfect. Okay. So what is the limit as x approaches 0? So we have a left-hand limit at -infinity and a right-hand limit at infinity. So what would be the limit as x approaches 0 on this one? The limit as x approaches 0. So the overall limit would be what in this case? It's undefined. Yes, it doesn't exist. I mean, the limit doesn't exist because you are looking at it from both, trying to get the two of them to match, and there doesn't, and the limit does not exist. So we just simply say DNE. Okay, that's the best way to deal with that. Okay, hopefully we're good so far. All right. Now, we need to be able to draw step or piecewise function. So this would be a good practice for you on your own. And maybe I should go to a Jamboard on this one. But anyway, I'm just gonna stick with this for now as on the shared board that we're doing. And then we're gonna try to answer some questions after that based on the drawing that we're about to do. So what I would suggest you do is to try to get a little piece of graph paper somewhere and follow along with me, because there are 3 parts to this graph. You can define a function by saying that when it's less than this, it's one thing. When it's greater than this, it's another thing, and so on and so forth. So here's what we're saying. When you're less than or equal to 0, so including when you're 0, the function is just simply 4. right? Can anybody suggest what that might look like on the graph, right? It says that when x is less than 0, this function needs to be just 4, always 4 once you're less than 0. What should that look like on a graph? Can anybody suggest what that might look like on the graph? A straight line from minus infinity until 0. Thank you, Stephen. Well done. So that's exactly what we're going to do. I'm going to put a straight line in, and you should be able to do this on your own, by the way. I'm going to put a straight line in going from here to here. And it's not the straightest line. Let me see if I can fix that just a little bit. Okay, maybe that's a little better, a little bit better. Now notice that I didn't put a circle on that 4 because the function is 4 at 0. If it wasn't, I put an open circle on that. So Stephen is right? It's a straight line going from minus infinity until 0. Then it says between 0 and 2, 0 not included, by the way, it's 2x minus 3. Okay, so I know that a 2x minus 3 means it has a slope of 2 and it has a y-intercept of minus 3. You guys were drawing graphs the other day. This is part of what you were expected to be able to do, put your graph together. So I'm gonna show you what this graph should look like then. Now, understand that at 0, this graph is not going to be on this line here. It's not going to be on the 2x minus 3. So what I'm going to do is I'm going to put a circle on that. All right, I'm going to put a little open circle on that, like here. Where am I on this thing here? Okay, there we go. I'm going to put an open circle here. Then from there, I'm going to put a line in that has a slope of 2. And I'm only going to go as far as 2 on this. So I'm going to go up 2 and across 1. I'm going to put another point right here. I'm going to go up 2 and across 1, put another point right here. And I'm going to say that my line needs to be a straight line, 2 over 1. Yes, Danny, right, exactly. Up 2 and across 1. All right, that's my slope. But I'm going to stop my graph at 2 because remember, this section of the graph, which has a slope of 2 and a y-intercept of minus 3, only goes up to 2. 2 included, by the way. So that's a solid dot right there. So I'm going to put my line in now. That goes from here, this part of the circle here, goes through that point and stops right there. Okay? All right. I'm reminding you, you need to be able to do this yourself. All right. So maybe I need to extend this just a little bit more so it hits right there. Okay, I think that's a little bit better. So understand now that this graph, right, does not exist on this line at 0. It exists on this line up here. That's where the graph is when you're at 0. When you're at 0, you're up here at 4, you're not down here. But once you cross over 0, until you get to 2, you're going to be traveling along this line. Right? If any of you have ever written computer programs, you know that you can set conditions. So when x is greater than this or less than that, here is what you need to do. When x is okay. Let's see if we can do the other part now. So when you're greater than 2, so anything above 2, you're going to have a quadratic function of minus x squared plus 4. So here's where some of those skills that you were using to draw those graphs would come in really, really handy. Minus x squared plus 4. So what I know about that graph is that graph is going to be a quadratic, and it's an upside down quadratic. And I know I'm going to use a dotted line for part of this. So here's what I'm going to do. I'm going to start here. All right, let me see if I can find the dotted line thing. That's probably, where is it now? I know that there is a, maybe it's not that one. There's one that you can use. All right, I'll just, yeah, it's okay. What I'll do is I'll just simply draw the line in. All right. So I know that one point on the line would start off here, but that point is not a point that I'm prepared to use. Why don't I figure out what the value of the function is at 2 and then go from there? Then put 2, 3, and 4 in, and then see if I can come up with a reasonable line from there. So I'm going to find the f of 2. Oh, sorry. I'm going to find the f of 2, the f of 3, and the f of 4. All right, see if we can fit those on the graph. Well, if I put 2 into this function, remember I'm putting it into this function here. If I put 2 into that function, I'm going to get minus 2 squared, right, which is 4, and that's minus 4 plus 4, which is 0. That's going to take me down here. I'm going to put another open circle here, right, because it says when it's greater than 2, so it's not including that value. And then I'm going to put in for 3, so that would be 3 squared, which is 9, and that's minus 9 plus 4, which is minus 5. Oh, that's all the way down here. That's further than I can actually put this in. It's at minus 5. All right. I'm not going to be able to put in for 4. So I'm going to put in a line that looks something like this then. And it goes down further. This line, by the way, also continues on the other side. Right? At 3, it goes down to minus 5. Unless I'm making a mistake. Let me just double check that. So that's minus 9 plus 4, that's minus 5. Okay. So here's my, not very pretty, but there's my graph, right? It's 3 parts of the graph. Now notice that there are some circles on there which suggest something about what happens at those particular points. So let's just be clear now. At 0, the value of the function is 4, right? Not minus 3, it's 4. At 2, the value of the function is 1. It's not 0, right? Even though when you put 2 into, let's say, for instance, this function right here, you're going to get 0. You have to look at the part of the function that relates to the various parts of the domain, right? That's what you need to pay attention to. Okay, so let's get to these limits now. Let's see if we can answer these limits. All right, so these limits are what we're going to try to answer for various parts of the function. Let's start off with the limit as x approaches 0. All right, have I lost anybody so far? I just want to make sure my graph made sense and that we're good to go. All right, Anika, how about you? Are we okay so far? All right, tell me if you're okay. Okay, fine. Okay, let's start off with the first one. What's the limit as x approaches 0? Well, what we're going to do is we're going to go through and answer the question from the two sides as we normally do. And let's see if we can come up with what the limit is. So we make it only halfway. Let's go back and answer Kush's question now. So make it only halfway, like the graph. Yeah, I can't go any further with the x squared minus x squared plus 4 because my graph doesn't go down far enough. Okay, a straight line from minus infinity until 0. Yes. Okay, so you're trying, so you're, okay, let me see if I, okay, yeah, okay, right. So, okay, so let me get back to this now. So limit as x approaches 0. So let's get to the limit as x approaches 0 from the left first. What is that equal to? And what do you think, folks? I think it's time for me to bring the wheel out. Yeah, let me go get my wheel here because I want everybody to get involved in this. Let me see if I have the right wheel going here. Is this? Yeah, this is the right wheel. Perfect. Okay, so let me don't put any answers in yet. I think I've done enough of these now that everybody should be more comfortable with this. All right. And it looks like we have Vanessa coming up first. Vanessa, you are the winner of the prize. No, you're not going to Vegas or anything. The Wheel of Anxiety, according to Danny. Vanessa, you're with us, right? Wheel of Misfortune. You guys are. It is not bad. Come on. Anyway, so Vanessa, let's go right hand. Let's go left hand. Let's do all of that. Okay, Alexander, don't put any answers in now, please. Just hang on, please. Just hang on. All right. So let me start off with the limit as x approaches 0 from the left. Let me make sure you can see the graph. So as you approach 0 from the left, what would you say the answer is for the negative first, Vanessa? And as usual, I always say if you need help, you just let me know, and I'm quite happy to help you out with that. So you're saying it's minus 4, and I agree. Any answer that you see us get that doesn't make sense, stop me. Excuse me 1 second, please. Just getting a little water there. Okay, so I agree with that. What's the limit now as x approaches 0 from the right? How did we get that? Okay, Sarah, I appreciate that question. Why is it -4? Sarah is asking. Okay, so let me answer that question for Sarah and Sarah. Am I pronouncing that right, by the way, Sarah? Is that the correct pronunciation, Sarah? Okay, perfect. All right. So let's answer the question for both of you. Let's look at the graph, right? As I get closer, so remember now, I'm asking the question as I approach from the left. That's what 0 minus means. So let me go up and let me put an arrow in, a red arrow, which is going this way, right, along the x-axis. I'm trying to get to 0. As I get closer and closer to 0, I should be looking at this line here that I'm pointing to right now. This is the line, right, that I'm waving my thing back and forth on. That's going to take me closer and closer to 0. So what value of x, sorry, what value of y, not x, what value of y is the function getting closer and closer to? Well, the fact is that anywhere between -infinity and 0, the graph is always 4, positive 4. Oh, hold on. Why did I say -4? Why am I saying -4? Who has, it isn't -4. Sorry. Do I have -4? Is that what I wrote down? Is that what I wrote down? Yeah. Okay. No, I understand why people are asking me questions. You're asking me questions because I wrote down something that's wrong. It's not -4. I take that back. So putting in the positive 4, Sarah, does that make, and Sarah, does that make more sense now? Okay, yes, yes. What I had before was just wrong, right? I might just edit that out of the video because that was embarrassing. That was terrible. Yeah, I should probably take that out of the video. Anyway, so positive 4 is what we have for, yes, Vanessa, thank you very much. So is everybody clear on positive 4 now? What Vanessa said is not what I wrote down. What Vanessa said was right. What I wrote down was wrong. So positive 4 is perfect. Okay, now let's get to, well, let me go spin again. Let me go spin again. We're going to ask about what happens when I'm going from the other. Vanessa, you're out for today. So not that you should relax. You should still stay with us, but you're good for today. All right. And Thomas, you're up next. And please don't tell me that you weren't here before. What we've done is stuff that you've been in the class since we started. So and you can ask for help if you need it. But what we're asking you to do is to look at the graph now as you're going from this side. I'm going to put an arrow in there for you, right? So now as you're going this way, right, look at the part of the graph. And by the way, Thomas, you're there, right? Perfect. So you're saying -3. Thomas isn't wasting any time at all. Okay then, Thomas. He's right. It's equal to -3. Is everybody okay with that answer, first of all, before I go any further? All right. Is there anybody who isn't sure about that answer? The -3. Okay, perfect. Okay. So what is the limit, right? What therefore is the limit? So that we've done the left and we've done the right. What is the limit as x approaches 0 in that case? What is that equal to? We've looked at it from the left. We've looked at it from, why is it -3? Okay, Alicia is asking. Thank you. Thank you very much. Hope I didn't screw up this time, but let's make sure, Anika and Alicia, that I did it okay this time. So let's go back and look at the graph again. So as I'm getting closer and closer to 0, but coming from the right-hand side this time, Alicia, not from the left and not from, so not going from, so you see that this red arrow I just put on there, that's the one I want to look at. So look at the part of the graph that's relevant now to getting closer to 0. It's not this part up here anymore. It's this part of the graph right here. It's this part that's between 0 and 2 for me to get close to 0 from the right now. So as I'm getting closer and closer, as I'm getting closer and closer and closer, if you follow what's happening, my y value seems to be trending towards that -3. Do you see what I'm saying, Alicia and Anika? Do you see that the graph is moving? Look at it's the y value that you want to focus on. So as I get closer and closer to 0 on the x, what y value am I approaching? Right? What is the y value? And I'm not looking over here on this side of the graph anymore because I want to approach it from the right-hand side. So Alicia and Anika, does that make sense now? Why we're going from the other side? So I want to make sure. Okay. Nika says yes. Well, how about Alicia? All right, I don't want to leave anybody behind. Okay, folks. And you know that when I do this wheel spinning thing and people get a little anxious and all that kind of thing, I do press people when they're not sure, but that's the nature of how I do this thing that I call teaching, right? I don't want to leave anybody behind. So it means that the rest of us have to be patient for a while until we all get caught up on what we're doing, then so be it, right? That's the way this works. Okay, let's keep going. So what about the limit now? To answer the question, what is the limit? So we looked at the left, looked at the right. We got 4 in one case, we got -3 in the other. So what's the limit as x approaches 0 then? Right? What is the limit? It's a DNE. There you go. That's an absolute DNE. Does not exist. Does not exist. All right. Thank you, Ashfan. Okay. So we're going to be asking the same questions now. It says x approaches 2. So we're going to ask the question from the right, and I don't want anybody putting any answers in yet. Right? I'll tell you in a minute who is going to answer that question. So I'm asking for the limit. Drop a line down here. The limit as x approaches 2 from the, let's say from the left first. What is that equal to? All right, so let me come over here, take out Thomas, and let's direct that question to the winner of the wheel prize, if you want to call that. But anyway, Zach, where are you at? Are you there, Zach? Where is Zach? Where is Zach? Okay, I am looking for Zach. Zach is here. Okay, can I move up the screen a bit? Sure I can. Sure I can. Okay, so Zach, let's answer that question. I'm asking for the limit. I'm starting off from the left, right? What is the limit as x approaches 2 from the left? From the left. Go ahead, Zach, your time. And again, if you need help, just let me know. So I'm looking at it going from the left. Is it 3? It's not. It's not. So let's work our way through this then, Zach. I'm quite happy to help you out with this. Let's agree on this, Zach. The part of the graph that I should be looking at right now is this part right here. Can we agree on that? Because if I'm trying to approach 2 from the left, okay, good. So follow the x-axis. Move along the x-axis and along that graph and see what y value the graph is moving towards. So you're moving along the x-axis and you're moving along the graph. So follow the graph and move closer and closer to the 2 and look to see what y value the function seems to be pointing to. Does that help you out? And if you can give me an answer now, please. So look at the section of the graph I'm talking about and follow along the x. Sorry, how do we know to look at the linear line to find the answer? That's a good question, Ariana. Zach, by the way, you're right. How do we know to look at the linear part? Okay, because I'm asking for as x approaches 2. It's going to be one of 2 lines then, Ariana. It's either going to be this line, right? Because those are the lines that are closest to the 2. But the one that's closest to the 2 on the left is the one that is the straight line, Ariana. Does that help you out? And thank you for that question, by the way. And just like what Ariana just did, I'm always encouraging you to ask. And it shows that not only that Ariana is paying attention, but that she's doing what I've always asked of students. Ask when you're not sure. Okay, so back to Zach. Zach now says the answer is 1, and I agree. The answer is in fact 1. Okay, good. Thank you, Ariana, for the question. Thank you, Zach, for the answer. Let me come back over here now, and Zach, you're off the hook for today. I'm going to be asking the same question now about the limit as x approaches 2 from the right, and that question is going to go to Jordan. Jordan, you win the prize. Are you there, Jordan? Perfect. Okay, so let me show you the graph again. Let me write this down first. The limit as x approaches 2 from the right. So Jordan, over to you. What's your answer? See if you would, without me prompting. If you need prompts, that I'm quite happy to help you out. But if not, what's your answer? Would it be 0? Sounds like you're not so sure. Sounds like you're not sure. Okay, let me not give you a hard time. It is 0. It is 0 because as you get closer and closer to 2, but coming from the right, it is approaching 2. Sorry, 0. It is approaching 0. Okay. Now understand that at 2, the function's value is in fact 1, just so that we're clear. It is in fact 1, it's not 2. But so Jordan, thank you very much. You sound like you're not so sure though. Does that once you look at it some more, are you a little bit more sure now that you said it's 0? What do you think? Yeah. Okay. Good. All right. Let's get to -2 now. All right. Let's get to -2. So Jordan, off the hook for today. Right. It's good when you get this out of the way early, so that when the tougher questions come, you know that you're safe for today. All right. So my next person is it Anika? Yes, it looks like it's Anika. Anika, over to you. Are you there, Anika? Perfect. Okay, so let me write down what I'm asking you. What's the limit as x approaches -2 minus? Let me erase that. And I'll come back up to the graph in a minute, so you can see what's going on. Equals, okay. Okay, so Anika, what would you say? It's a little untidy right now. Let me try to clean this up a bit. Let me try to clean that up a bit. Okay, so what would you say is the limit as x approaches -2 from the left, first of all? Go ahead, please. So -2 from the left. See if you can figure out what part of the graph. Let me erase some more stuff here that we don't really need right now, unless you need me to put it back later on. Let me just put this back on here. Okay, sorry. All right, Anika, what do you think? As x approaches, is it -4? Whenever I see a question sign, I always wonder. Anyway, I'm not gonna give you a hard time. I'm just gonna say yes, you're right. It is equal to -4. Okay, and that's because it's not equal to minus. Yeah, I don't know why I'm saying that at all. It's not equal to the -4. No. Yes, Sarah is right. It's not -4. It is 4. Yes, it is +4. And you actually said +4. I'm stuck on this old -4 thing. I don't know why. I don't know where this minus is coming from every time. Anyway, so +4 is right. All right. And thank you, Anika. You are right. I just wrote it down wrong. You didn't say -4. I did. All right. Okay. So Anika is off the hook for today. I'm going to ask you the same question about going from the right, by the way, so be prepared to answer that. And that goes to Alexander. Alexander, are you there with us, Alexander? And, wow, the answer is already there. So the limit as x approaches -2 from the right, Alexander says it is +4. Okay, so what is the limit then? So now we've answered both of those questions. Nobody put any answers in there yet, right? The question I'm about to ask is this. What is the limit as x approaches -2? So not -2 plus, not -2 minus, just what's the limit as x? Don't put any answers in, please. Nobody, right? I'm about to ask a specific person for that answer. Okay, so this one we said was D and E. I forgot to write that in. The other one was also D and E, the one before that. And Adam, over to you. Adam, where are those answers coming from? Adam, your answer is 4. Yeah. That's sorry. Yeah, okay, yeah. The answer is in fact 4, right? So no negatives there. I mean, I don't know why I kept putting those negatives in before. Thank you very much. Thank you, Adam. So that is really all it's all about. I mean, it's just a matter of putting those numbers in, looking at it from the two sides, and then calculating the limits. Okay? Hopefully we're good with this thing so far. Okay, now to get a little bit more difficult. Evaluate the following limits using an appropriate strategy. Okay. So, okay, I'm not going to call anybody. I'm not going to use the wheel right now. Let's just throw it out to the class. Clearly, I can't just put 2 into the function. That would be a problem. This kind of looks like when we were doing this before, where we couldn't just throw the number in, we would have an issue. So any suggestions? So let's talk about A first. So let's focus on this one first. Any suggestions as to how we might be able to tackle the limit here? You simplify it. Thank you. Tell me how you'd simplify it. How? Danny, give me some. We simplified it. When you say simplified, it's already kind of simplified already, but give me more specific when you say simplify, Anika and Danny. Simplify how? Difference of squares. There you go. We can factor it. So I think that's what we should have said. We should just go ahead and factor it. So if we factor it, what does that look like? Well, you know, a difference of squares means you're going to have 2 plus x and 2 minus x. Okay, hopefully that rings a bell. We've done that before. And the bottom is still 2 minus x. And this is a classic example of what I was showing before. This function has a hole in it, right? The function has a hole when x is equal to 2. So, yes, we know that we can cancel. And what we're left with is just simply 2 plus x. So, what's the limit? Essentially, as x approaches 2 of 2 plus x. And in a case like this, all we really need to do is just plug in the 2, right? That is equal to, we don't really need a big fancy diagram for this one, right? This is really just a straight line, but a straight line with a hole. That's what we're saying. It's a straight line with a hole. So we're just going to plug in the 2 into that, and that would be equal to 4. The function is approaching 4 as I approach 2, even though at 2, let me be clear, at 2, this function does not exist, right? The function doesn't exist at 2. The function is undefined at 2, right? I put 2 into the original function, I have a problem. But when I reduce it down, I find that what would happen is, and you know what, maybe I should, all right, if I had time, I would put it on a Desmos graph and show you what I meant. But actually, I just use a regular, I did show it to you before, so I'll just skip that. But if the answer to the question is that the limit is 4, right? That's just plain and simple 4. Okay, how about the next one? Should we also try using some kind of a factoring strategy on that? What do you say, folks? It's asking as the limit approaches minus 2. Now, I can tell you right now that putting minus 2 into this function is a problem. All right, Dan, you're saying simplify. I know you meant factor, right? Because it's already kind of simplified in the sense that all of the like terms are already put together. But why would it be a problem? Okay, Sarah, let's find out why it would be a problem. Let's try putting minus 2 into this function. So let's say the denominator. You know that when the denominator is 0, we have a problem, right, Sarah? You're clear on that. Isn't that true? Okay, so let's put minus 2 into this. So we're gonna get I'm just looking at the denominator now. Minus 2 squared plus 7 times minus 2 plus 10. Excuse me. This is just simply 4 minus 14 plus 10. I see a problem there. Agree with me, Sarah? Yeah. I can't just put minus 2 into that. I'm going to end up with a 0 denominator, which is a problem. So I'm going to scratch that and say, no can do. Not going to work. But Danny was mentioning factoring. He didn't actually say factor, but he meant factoring. So why don't we try that? So I can factor the denominator easy enough. That's lightweight, grade 10 stuff. So it's x plus 5 x plus 2. I'm pretty sure everybody is okay with that. Can the top be factored that easily? I know we learned some of that stuff back in the advanced functions thing last year. How would you factor that? Okay, Danny says it can be factored, but how? I mean, if I got this on a test, what am I supposed to do? Right? You said factor it. That sounds nice, but how am I supposed to factor it? Long division, Sarah, Ashvan, Kushi, trial and error, synthetic or long division. Richard and Sarah and everybody else. Interesting. Here's something I taught my class, which you may or may not have learned in your class. Sometimes you don't need to do long division with by grouping. Tommy Leo, one of my stars from I think I had you in what the first quad. Yeah, absolutely. Do we know when we can use grouping though? What's the rule about that? Do we know if grouping can be used in this case? That's the question I want to ask you. Right? Do we know the test of when something can be grouped? Does anybody remember that? Either Danny, Tomley, or anybody else I had in my quad one. Right? What's the rule about when we know we can factor by grouping? Nobody remember that from quad? Was that too long ago? Right? What is that? Like 4 months ago? Too far back? Right? I'll tell you what the rule is that tells you that you can factor by grouping. Right? Look at the coefficient of the first term, the x squared term, and the constant. Multiply those two together. Yeah, we'll get to that, Danny. Multiply those two together. Look at the coefficient of the two middle terms. So the x squared term and the term that is just simply x. Multiply those two together. If the product of the coefficient of the x cubed and the constant is equal to the product of the inside term, you can factor by grouping. FYI. All right? Let me say that again. If you ever have a polynomial, which is a cubic function, and the first term, which is the x to the power of 3 term, has a coefficient which, when multiplied by the constant, is equal to the term that has the x squared times the term that has the x to the power 1. If when you take that product, they're equal, guess what? You can factor by grouping. So 1 times minus 8 and 2 times minus 4. Both of these are equal to minus 8. So I can factor by grouping. I can confidently factor by grouping. What does factor by grouping look like? And I'm saying this to you because I don't want you to be running off doing trial and error and doing long division when you can factor by grouping, right? Factor by grouping is so much quicker and so much easier. So let me show you how that works. Let me tackle that first top term again and say, what's the common factor? Let me erase this part right here. What is the common factor between the very first two terms? What is the common factor between those two terms? X cubed and 2x squared. What's the common factor? X squared. So I'm going to write down x squared, and I'm going to factor out what you get from factoring x squared out. I think you're going to agree it's going to be x plus 2. Okay? What is the common factor between the second two terms, between the minus 4x and the minus 8? What's that common factor? Minus 4. So minus 4, I'm going to end up with x plus 2. All right? Hopefully everybody agrees with that. And hopefully you guys who I had in the first quadrant, this is looking familiar to you, by the way. All right, so now I have another common factor between these two of x plus 2. So it's now x plus 2 is my common factor between both of these. And then the other part of that would be x squared minus 4. Okay. And that can be further factored into x plus 2, x plus 2, and x minus 2. Okay. Have I lost anybody? Is everybody still with me? And all of this, remember, was over the x plus 2. Was it x plus 2? X plus 5, x plus 2, sorry. X plus 5, x plus 2. That was always the case. Yes, Sarah. Yes, Ashvan. So much easier, right? No, you can't always factor by grouping. But if you try that little test I just showed you and it works, you hit the jackpot, right? It's so much easier to factor by grouping. All right, so here we go. What we're really asking then is what is this limit? Whoa, I didn't mean to do that. All right, what we're really asking then, put that back there. Okay, what we're really asking then is what is this limit? What's the limit? Oh, first of all, let's just reduce this because obviously that's part of what we need to do. Let's take that. Let me use a different color for that actually. Let's take this with this, reduce it down. So what we're really left with at the end of the day is the limit as x approaches 2. No, what is it? X approaches minus 2. As x approaches minus 2 for this thing. X plus 2, x plus 2 over x plus 5. This is not going to cause us a problem, right? We can confidently put minus 2 as our denominator for x, and it doesn't give us 0. It doesn't give us 0 at all. So it's x plus 2. Was it x plus 2, x minus 2? It is. Why do I keep doing this nonsense? Sorry, folks. Sorry. Yeah, you're right. You're right. I'm glad. I'm not doing this on purpose, by the way, but I'm glad that people are pointing these things out to me so that I know that people are paying attention. Thank you very much. Thank you. Thank you all. Thank you, Ariana. And thank you, everybody who pointed that out. All right. Okay. So it's x plus 2 and x minus 2. All right. So let's put in the minus 2 into this. That's not a problem at all, right? What are people getting by putting minus 2 into this function? Can you tell me what that answer is? 1, Adam is saying. I'm not getting 1, personally. I'm getting something else. Ashvan, I'm going to agree with Ashvan on that one. I'm getting 0, right? That is actually equal to 0. Okay? Hopefully that makes sense because one of the brackets becomes 0. Remember, a 0 numerator is not a problem. A 0 denominator is a problem. So when the denominator is 0 is when we have a problem. No idea. I managed to put something into my calculator that returned a 1. Ooh, really? I'm going to say, Adam, that has to do with order of operation. That's my guess. It is 0. Yes. Not yes. It must have something to do with order of operation. Anyway, because I suspect what happened is that you got these two, then it divided by x, and then it added the 5 on at the end. I'm pretty sure that's what happened. But anyway, let's keep moving here. All right, so that one was not as hard as it looked because we can factor, and the factor is not as hard as it looked because we can factor by grouping. So bear that in mind. That might come up again. And what's the test of factor by grouping? First coefficient times constant is equal to middle coefficient, the two middle coefficients. If it passes that test, you're good to go. You're good to go. All right. Let's look at C, continued. X squared minus 5, x squared minus 5x plus 6. X squared minus 5x plus 6. No. Does the same idea hold? Is the question. We have x squared minus 5x plus 6 and x squared. Can I just, what do I do in a case like this? Is putting in the 4 going to cause us a problem? That's the question I have for you. Does putting in the 4 cause a problem? What do you think? Anybody? It does not. Check it out for yourself. At the bottom of this, let's just plug the 4 in and see what happens. So the top becomes, so the limit as x approaches 4 is 4 squared minus 5 over 4 squared minus 5 times 4 plus 6. The limit as x approaches 4 is, top of this is 16 minus 5, which is 11, over, is that 16 minus 20, that's minus 4, plus that's 2, I believe, 11 over 2. All right. And again, folks, if I'm wrong, you jump in there and let me know if I'm wrong. I did that in my head, so I could very well be wrong. So 16 minus 20, I'm going to get minus 4 plus 6. I think that's right. Okay, right. So guess what? Sometimes getting a limit is as easy as just throwing the number into the function. If there is no real issue with it, then don't sweat it. Okay? I mean, the fact is that sometimes all you really need to do is to actually plug the number in and you're done. Okay? So I plugged in the number, I got 11 over 2. That's the answer. Right? The function is approaching 11 over 2 as the answer. Okay. Well, here's the thing, and I hope we can get through as much of this as possible today, because obviously we're getting closer to the end of the class already. And there's quite a few of these more left that we need to get done. But look at the second one. I give you a hint here saying factor theorem for D. So the problem is with this one, and we're going to go through it anyway. The problem with this one is that this doesn't have that nice little convenient factor by grouping approach. When I take this number and I multiply it by that number, it's not the same as this number multiplied by that number. Unfortunately, it's not. All right. In one case, you get 1 times 3, which is 3. In the other case, you get minus 5 times 1, which is minus 5. It doesn't work. So we obviously have to do something else. The bottom is easy. Bottom is a quadratic. We can easily put a quadratic in. And by the way, putting in 1 into the bottom isn't good either. You're going to get 1 minus 2 plus 1, which clearly is going to be undefined. So this means we're going to have to dig back into that stuff that we did in advanced functions to make this magic happen. This, I'm hoping everybody remembers. How do we do it? Right? I can't factor by grouping, so what do we do? When that option, that shortcut method is no longer available, what do we do? So x minus 1 squared, oh, that's for the bottom. Okay, Kushi, that's for the bottom. So factor the top. Yes, well, how do we do the factor the top? Sarah says long division. So she's right? But it does mean getting the first x by trial and error. It just means that. That's just the unfortunate nature of things. And you hope that the teacher is kind enough to come up with a number which is easy to work with. So let's hope that Mr. Campbell, whoever wrote this question, made it either like 1 or minus 1 or 2 or minus 2. So we don't have to go much further with this. So let's try 1. So remember, with the factor theorem and with long division and that kind of thing, we do have to find the first 0 by trial and error. So let's see. Let's try 1 cubed plus 1 squared minus 5 times 1 plus 3. Let's see if that works. Everybody's on the same page with me here, hopefully. Well, Danny, how did you get that already? I don't know if that's right or not. I don't know. Danny seems to think that he has the answer, but we'll see. Well, 1 plus 1, that would be 2 plus 3 is 5 minus 5. So we know that 1 works, so x minus 1 is a factor. I hope you all did long division. Synthetic division. I hope that's something that you did. So I'm going to put, say, x minus 1 is a factor. Come on. And I'm going to put 1 here and 1. And did everybody do synthetic division, by the way, in quad 1? I know my students did it, clearly. I mean, that's what we did. But did everybody... I did not know. You didn't. Oh, okay. Well, folks, whatever worked for you when you did this before. I mean, if you want to come back and we can do this in the 3 to 3:30 period, we can do that. I mean, I can't teach it to you right now, but I'm just going to go through the process. So minus 5 and plus 3, bring down the 1. So that would be minus 1 there. This would be 2. This is minus 2 here. 5 essentially plus 2, which is minus 3. So this is 3. So we're left with, the first one is x minus 1. The second bracket is x squared plus 2x minus 3. So I factored it to that point. And then let's see now, that would be x minus 1. And then this looks like x minus 1, x plus 3. Yeah, that looks like it's right. So let me put this all together now. I know that some of what I'm doing now Yeah, the x minus 1 squared. Yeah, you were right about that all along. So the top of this is this thing that we just got. The bottom of this would be factoring the, it's really x minus 1 times x minus 1, I believe. Let me just double check that. Let me just double check that. X minus, yeah, it is x minus 1, x minus 1. So guess what? Final answer is a lot of stuff cancels out. We're left with x plus 3. All right? Am I expecting you to be able to do this? Uh-huh. Yes. Yes. The simple answer is yes. All right. So the answer to the question now is, what is the limit as x approaches 1 for x plus 3? And the answer, of course, is just simply 4. Just simply 4. Okay. All right. 11:23. Clock is running, and we're gonna do as much as we can. Let's move on here. Now, what about as x approaches infinity? Ooh, okay. Hint is horizontal or oblique asymptote. For those of you who remember back to these rational functions, I'm not even going to try to factor this because that's not the approach here for when you're trying to find out as x approaches infinity. What I'm going to ask you is this. Do you remember, and this is for the whole class, I'm not just talking to my students, I don't want to make it sound as if I'm just like a reunion with me and my former students. It's for everybody. Do you remember when you were looking at rational functions, you had different kinds of asymptotes, horizontal asymptotes, oblique asymptotes, vertical asymptotes, all this other stuff? I want us to focus right now on horizontal asymptotes, right? Look at that first function, right? So I'm talking about this baby right here, that one right there. Can we tell what kind of asymptote it has, right? Do we know what kind it has and what the asymptote actually is? Does anybody remember this from quad 1 or quad 2 whenever you did advanced functions? Does anybody know what the asymptote is, whether it's vertical, horizontal? What's going on here, folks? Anybody? Please don't tell me that was too long ago for you to remember this. Right? There's no wheel spinning here. Nobody has to worry about me targeting them. It is a horizontal asymptote, Alexander. Great, Kushi. Good. Good. Do we know what the equation of this asymptote is? Do we know the equation of this asymptote? That is the question. Right? It's a y equals something. I'm not even trying to factor this. Maybe it's factorable. I don't know. I'm not even trying right now. Right? I'm asking you whether you know what the equation of the asymptote is. So y equals 5 over 4, I'm getting. Y equals 3 over 5 is the correct answer. Now, where is he getting that from? Anika, yes. The value of y, which leads to the whole equation, 0. Well, here's what I would have taught. Value of y, which, okay. Here's what I would. There are two ways I'm gonna show you this, right? Excuse me. To get the horizontal asymptote of a rational function where the degree of the numerator and the denominator are the same, which it is, they're both second degree functions. The top is x squared, the bottom is 5x squared. So they're both second degree functions. Is you take what's called the ratio of the lead coefficients. The ratio of the lead coefficients. So in this case, the lead coefficient on top is 3. The lead coefficient on the bottom is 5. What's the ratio of those two things? It's what Anika said. It's what Sarah said, right? It's what, who else? It's what Danny said, and Ashvan, and all these other people said. The only thing I'd say to them is that it's a y equals line, right? It's always the equation of a line. So it's y equals 3 over 5, because you just take that ratio of those two lead coefficients. Now, if you think about what this function might look like, and I don't really know what it looks like. If there's a horizontal asymptote, let me just put it this way. Let me just cut to the chase here. If there is a horizontal asymptote, as the function moves towards infinity, the function is going to move towards whatever that horizontal asymptote is. Because that's what's happening. right? The function, if there's a horizontal asymptote, as you move further and further to the right, which is where positive infinity is, the function getting closer and closer to whatever that horizontal asymptote is. How do we get the HA? Just by looking at it, Sarah is saying. We get the HA, thank you for the question. You get the HA by just looking at it, by asking the question, first of all, if the degree of the numerator and denominator are the same, okay? If they're the same, let me give you the general rule, Sarah, and thank you for asking, by the way. The general rule is, if the degree of the numerator and denominator are the same, which it is, you'll agree with me on that, right, Sarah? That the degree of the numerator is 2 and the degree of the denominator is also 2. So if they're both equal, then we take the ratio of the lead coefficients. The lead coefficient on the top is 3. The lead coefficient on the bottom is 5. So we put the 3 over the 5, right? So that's it. That's all it is. So as the function gets bigger and bigger and bigger, the function moves towards whatever that horizontal asymptote is, which in this case is y equals 3 over 5 line. Okay, so the answer to the question is the limit as x moves towards, there's another way to do this, by the way, which I probably should show you. As x moves towards infinity, is that this approaches the 3 over 5. As you go further and further and further out and this works from negative infinity and for positive infinity, just so we know. Now, let me quickly mention the second one. So that's the answer, by the way. The limit as it approaches infinity is 3 over 5. Don't try, if you could factor it, then yeah, try to factor it, absolutely. But the truth is that, at the end of the day, if it works out to that it can't be factored, or that you still have a function that has a degree of on the top of the bottom of being the same, let's say the lead coefficients, and that would be the answer. Now, what happens when the top has a higher degree than the bottom? Does anybody know what happens in that? Oh, let me just mention something else. When the bottom has a higher degree than the top, which is the other way around, not the case that we have here for this. This is not the case here. The case here is the top is bigger than the bottom. But when the top is lower than the bottom, then the horizontal asymptote is the x-axis. It's the y equals 0 line, just so you know. But what happens when the top of the function has a higher degree than the bottom? Does anybody know what kind of asymptote we get in that case? Does anybody remember, I should say, because you're supposed to know this from advanced functions? Okay, oblique asymptote. Thank you, Adam. It has an oblique asymptote. So because it has an oblique asymptote, what's happening is that the function is either continuously rising as you go towards infinity, or is continuously falling as you go, depending on whatever that oblique asymptote is, right? But the fact is that it is not. There's no limit to the function really, because it's just going towards infinity. So when you get a case where you have an oblique asymptote, the function is not going to have a limit. The function is just going to go on to infinity as you go from left to right. So I'm going to try to see if I can squeeze in, I don't know. Let's at least look at one more question here before we go. How about this one? All right, so the answer to this question is that the limit does not exist, just so we know, right? The limit does not exist because it just goes on to infinity. Now, this is a one-sided limit that we're looking for here, right? In fact, I'll end on this note because we do obviously have to finish up the stuff on limits tomorrow, right? We have another double period tomorrow. 1 over x plus 3, if I'm just asking for a right-sided limit, right? So let me just show you very quickly what that function looks like, right? 1 over x minus 3 looks something like this. There's a horizontal, sorry, there's a vertical asymptote. This is what happens when I start to rush at the end of the class. There's a vertical asymptote at the x equals 3 line. So somewhere around here, there's a vertical asymptote at 3. The function basically looks like this. Right? That's what the function looks like. And you can put this on Desmos later on for your own edification. So I can actually ask the question, what is the limit as x approaches 3 from the right, which means I'm coming at it from this direction, and get an answer. Because as x approaches 3 from the right, the function is moving to, well, what do you say, folks? What's the limit as x approaches 3 from the right? From the right, not the overall limit. So it's plus infinity. It is plus infinity. All right. All right. So I'm not gonna finish the next one, right? But I'm gonna ask the question. And by the way, does plus infinity that Kushi and Ashvan said, does that make sense to everybody? Is everybody good with that answer? Yes? No? Are we good with that answer? Does that make sense? Okay, Adam says yes. Okay.